Now we have calculated the mean from pre-test and the mean from post-test. So we are going to go ahead and uh, calculate descriptive statistics. If you are in your working directory, you can just go down and find our file. Latest file is markedata.rdata, and here we are. If you open it, you can just see the variable you have. Extend here. You can see what we are going to calculate descriptive statistics from. We are going to use the mini pre and the mini post. Okay. All right. So we need to create our markdown as usual. And the first thing we need is create our chunks. The first chunk is to load necessary library, which is tidyverse, and deploy. Right, go ahead and run the chunk. The second one is descriptive statistics, and here we are now. So let's go back again and see the data. We have mini pre and mini post, and our variables, we have school name. We can see the situation among the schools, gender, accommodation, grade, school type. 1, 2, 3, 4, 5 possible variables. All right, we can just go little by little so that you can just clearly see. All right, let's call this analysis 1. We need to show our data. It's called marked data. Right, we pipe it so that pipe it so that it goes smooth by smooth. Okay, right, we are going to use mainly two functions and the other different analysis function. The first function to remember is group by. Here, group by what? A variable you want. Let's say the first one is a school name. Okay, we can group by school name and see school name. Okay, here. And now the second function to be used is summarize. Summarize this one. Please remember that, because we are going to summarize according to a grouped variable into our data variable, our data, let's say, column, which is mini pre or mini post. Okay, that is dependent variable. And so we group independent variable and we summarize from dependent variable. All right, or we group input and we summarize from output. All right, summarize, first thing we can summarize the mean of school name, mean, okay, let's call mean1 equal to, now the analysis function for mean is just mean. Okay, if you open, we need to select the dependent variable, it's mean pre. Okay, if we run this chunk, we can see here we get analysis 1, 8 observation of 2 variables. What is it? Please click on that, open, and see it. All right, you can see since we have analyzed into school variable, we can see school A, school B, school C, school D, school E, school F, school G, and school H. All right, alongside their mean. Okay, so this is good because you need to see before intervention if the schools were on same level, which is not the case. I think this school G and H, F maybe on same level, but school E and the school D low level, and school C, school A high level, and the school B medium level. You see the school even before pretest they were not at same level, so many assumptions here were invalid. All right, let's go back. So you can see you can change the variables. Let's see a next variable, which is gender. If you run this code, then you can see how gender is. All right, so female got 33 in pretest and the male got 40, so the gender also were different before intervention. All right, so this is just exploring our data. Another variable is accommodation. Okay, if you run it, you can see the output. You see boarding school got 39% and the day school 34. Still closer, but it's still different. All right, but it's in nature because these are independent variables. All right. Next one is grade. Let's see into grade. If you run this, we can see results from grade. We have 2 grades, MPG and PCB. All right, perfect. So the grade doesn't make any impact here before intervention. That's good. And the last variable we have is school name or school type. Yes, school type. Okay, let's go and see what is the output. All right, rural had 35 and the urban school had 38. Closer but still different. All right, so you can see how to explore the 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 variables. All right, so let's just create another analysis to see how to combine more than, or how to group more than one variable. All right, you can call it analysis 2, and here we can get, yes, school type and the gender. All right, so you see we group more than one variable. All right, let's learn this and see. So we get analysis 2 here. We can come and see. All right, so our table has just grouped gender, and school type. So you see, female from rural school got 33. Female from urban school got 33. Okay, almost female student, whether they are from rural and urban, same result before intervention. Male students from rural school 37, male student from urban schools 42. All right, so you see there is an impact of urban alongside the rural students, rural school, uh, according to male students. All right, this is a just interesting. And now we have grouped two variables. We can also analyze at the same time pre and post. Okay, you just go at the end of parentheses, put comma and the enter. You go down main to main post test. Okay, you can name as you want. The formula or the function is the mean, then mean from post. Okay, run this one, and see. It is analysis 2. Yes. All right, we have got another column here. So we got an increase from female rural, an increase from female urban, an increase from male rural, and an increase from urban uh, urban. All right. So this is just a descriptive statistics to see the data, the results by our eyes. But later, after this video, we create another one for inferential statistics to see really if this increase had made a significant statistical significance. Okay, so this is just how we can combine. We can create another one to increase other statistical test. Let's call it a 3. Our data remain marked, and let's group just this and summarize mean one. Okay, all right. So we can just add more. Let's just go with the pretest only. Okay. So we can calculate standard deviation SD is equal, the function is SD and mean pre, just mean pre. Okay, if we run this code, we can see here 3. Okay, we can see based on pretest, we can see the standard deviation has also added. So you can see female urban. So urban got more standard deviation. All right. Okay. Let's go back and just add more here. Add more. Let's create median. Or just equals. Then the function is median. Here I opened of still mean play. All right, and run it and go check. All right, we have seen also median here added. That's good. We can go again, add sample size. Sample size is just n, and n you just open parentheses, it will know where to check this. All right, and you just run this code. If you go check, you can see also the sample has added there. All right, so this is just an example of how to explore descriptive statistics. For sample, a none of group combination has got more than a 30 sample, and this shows us that we need to use non-parametric test, but this is just for examples. But for example, we can combine these variables and analyze each variable so that we can increase the variable, the sample, if we want to use a parametric test. How? Here, we can use this and create another analysis. We can call it for what we do. We just combine only one variable so that we increase the sample. If you learn this one, now analysis 4 will come here and we can get this one. You see, because we are not combining many variables, so the sample is enough to analyze with inferential statistics. All right. Okay, so we have another analysis when we can increase here and add some test, but the tests that don't have automatic function in R, but we need to calculate them manually, such as mode and the standard error. If we want standard error, okay, we can still come here before just here and the SE doesn't have a function, so we needed to use a standard deviation of mini-pre, okay, over a sample, a square root of sample, square root of n, all right, a sample here. So put comma and run this code. So here we are, 3, analysis 3. We have got a standard error here, all right. So it will depend if you need standard error, all right. Actually, when you have a standard deviation, we also present sample, and when we have standard error, so we don't need standard deviation in the sample because it has used both of these statistics, all right. What else do we have to do? Okay, remember in analysis 2, we had mean 1, mean 2, yes, to mean pretest and mean post-test. So you can just go calculate each statistics for each mean, like standard deviation for pre, standard deviation for post, median for pre, median for post, etc. But you can just combine them if you want. All right, how to combine? Let's create another chunk so that it is clearly shown. Okay. We need to go back in our file called mark data. We need to, it has 58 variables. We need to add another variable, right? We can come here, mark the data. It will be the same name, and mark the data here, pipe it. Okay, so we need to mute it so that we create another column. We can call it mean or mean difference. This one will be equal from mean post minus mean pre. All right, if you hit this, we'll get marked data with 59 variables. Can we go and check it? Yes. Extend here and we see the last column. Yes, it was created. A difference from mean post and the mean pre is here. If it is minus, it means a student got higher score in pre-test. If it is positive, it means a student got higher in post-test, right? So actually, sometimes this is easy analysis when someone needed to combine pre and post test so that he can go ahead and just uh, calculate the descriptive statistics or inferential statistics all together. All right, because you can just use a t-test without even using ANOVA, because you have combined pre and post test, just analyzing the difference. All right, so we can come here, analyze this, let's call it 5, where we just use that here it's just mean. We can just use mean, and here we don't need to calculate pre. We will use that difference. It is called mean, and here we just edit to put just mean. Same here. Okay. If we run this, we can got analysis 5. If you open it, you can see now. Standard deviation and the standard error NA. What's wrong with this? Let's check. Okay, let's just change this name and see. All right, run it again and come here. Yes, the error is solved. All right, so this is how you can calculate from mini difference of post and pre-test results. All right, what else? I think this is it. So we have run how to calculate the descriptive statistics from only one variable. We have learned how to calculate descriptive statistics from more variables. We have just learned how to calculate more statistics, mean, standard deviation, median, standard error, sample, and you have learned how you can use pre and post mean differences. So you can go ahead and explore your variables. Let's say we need to put all our variables and combine them. Let's see, we can put school, maybe school name we don't need, but the combination, How is it? How is it? How is it? How is it? Let me check our variable again. We have school name, gender, accommodation, grade, okay? Can come here and add them. Gender, school type, accommodation, and grade. Know that as long as you are grouping many variables, then you will get a small sample, and somewhere you can't get something. All right. If you run this and go check, wow, you can see where you have NA, it means doesn't apply. You don't have enough data. For example, you have here only one combination, so you can't calculate inferential statistics with just combining only one sample, you see. But this is just interesting. You can explore your combine. For example, female student from rural school, from boarding school, from MPG grade, got this. Okay, got this. All right. So this is for just the reason why the mean is just small. It is because we have used the mean difference post from pretest. All right. Otherwise, if you use pre or post, you have to get more variables as we did before. All right. Thank you so much, and we will see in next video where we are going to start inferential statistics with t-test and more ANOVA and more variance ANOVA and more correlation statistics, and the lastly regression analysis.